Today we discuss about sediment grain size. Now, grain size, that is basically a textural term indicating the size of the detrital fragments or sedimentary grains which are basically produced due to different kinds of weathering. Now, to study a sedimentary rock, grain size study has huge importance. The study of size of the detrital fragments not only give us some input about the sedimentary condition or sedimentary environment, that is what agents, by which agents those sedimentary particles are carried out, but also it gives us some information about the transportation procedure, about the depositional condition, as well as we may get some information or we may get an idea about the distance up to which one particular size of grain may be transported by certain natural agents. And we all know that there are three natural agents: wind, water, and glacier. So depending on their density, as the density of ice, that is the glacier, water, and wind, they are vastly varied. So depending upon this density of these agents, the carried capacity or the carried grain size also differs. So thereby grain size study, in studying sedimentology or in studying a deep sedimentary deposition in an area, has huge importance to us. Now, whenever the many terminologies we used, but the first thing at scale, so there will be a miscommunication between scientists and between the layman's. Suppose this, I'm drawing a sedimentary grain having this size. At the same time, I'm drawing a sedimentary grain having this size. Now, for me, this one is a large size grain and this one is a smaller size grain. But this large and small terminologies, these are very relative. Maybe for some other person, this is large size grain, this is medium size grain, and this may be a small size grain. So depicting or describing a grain with these terminologies, large, small, this becomes very relative. So a grain which one people indicate as a large in size, that may not be large for some other person, that may be medium or that may be fine grain, that means smaller grain. So to avoid this relative terminology, relative use of grain size terms, peoples need a standardization. That means a scale by which we can measure or we can express the grain size unanimously throughout the world. So for this reason, in 1914, the famous scientist Arden, he proposed a sedimentary grade scale. And after 1914, in 1922, another scientist, Wentworth, he slightly modified the Arden grade scale, and nowadays it is known as Arden-Wentworth grade scale. Now, how did they divide the grain size class, or how did they express the grain size class? Arden, according to Arden and Wentworth, they use the grain diameter to depict the size of the grains, and according to their scale, they always use some standard divisions or standard classes which are either multiples of 2. Here you can see 2, and 2 to the power 2 is 4, 2 to the power 8 is 64. So always these are multiples of 2, and in the finer portions these are multiples of half. So 2's half is 1, 1's half is 0 0.5, 0 0.5 half is 0.25. So always it is either multiples of 2 in the higher side or decrease by multiples of half. That means again it's also a 2 to the power, it's a function of 2 to the power. So here it is 2 to the power 2, here it is 2 to the power 1, here it is 2 to the power 0. So like that, in that case is 1 by 4th is 2 to the power, sorry, 2 to the power minus 2. So you can see that all are multiples of 2, either higher values or lower values. So by this way we can get certain divisions, and according to these divisions certain names are proposed, such as the grain size having diameter from 2 millimeter to 1 by 16 millimeter, that is 0.0625 millimeter. They are represented as sand size. So nowadays, whenever people use in anywhere in the earth, in anywhere in the globe, whenever people use the term sand, the first thing it comes to a geologist mind that by the term sand, they used to mean the sedimentary grain having diameter ranging between 2 millimeter to 1 by 16 millimeter, that is 0.0625 millimeter. Similarly, for silt size class, the range is 0.0625 millimeter to 0.0039 millimeter, or 1 by 256 millimeter. And below this size, all the grains are known as clay, or they are known as mud. At the higher side of sand, the grain size ranges in diameter from 2 millimeter to 4 millimeter. They are known as granule. From 4 to 64 millimeter, they are known as pebble. 64 to 256 millimeter, they are known as cobble. And above 256 millimeter diameter grains, they all known as boulder. And together, these four size class, that is consisting of granules, pebble, cobble, and boulder, they are named as gravel. So this is the Arden-Wentworth grade scale by which the entire sedimentary grain size ranges, they are divided or they are grouped into certain classes, and the divisions of those classes are plotted either taking the multiples of 2 or the multiples of half, that is 1 by 2. So in this way, a standardized, globally followed, scientifically accepted, unanimous sedimentary grain size scale was proposed. Now, after the Arden-Wentworth grade scale, people find some problems, because whenever they try to do some kinds of mathematical calculations when they're studying the sedimentary grain size in sedimentology, the most frequent sediment size class one encountered in nature, that is from sand and below this size class. So these are the most frequently encountered sedimentary grains in nature. The higher side of the grains, that is the higher side from sand size, these are relatively rare. These are relatively rare. So people have to deal less with these size classes, that is the gravel size grains are less frequently deal by the geologist compared to this sand, silt and clay size particles. Now one problem people face, that whenever people try to do some kinds of mathematical calculation, they have to deal with these kinds of fractional values, 1 by 16, 1 by 64, 1 by 256, 1 by 2, these kinds of fractional values. Now any people in the world, if you want to, suppose you want to a mathematical calculation, a simple mathematical calculation is addition. Now if someone asked you to add 4 plus 2, so within a fraction of a second we will tell the result, that the result of addition between 4 and 2 is 6. Now at the same time, if the same people asked you to add these two values, that is 2 plus 1 by 16, then it will require a little bit of time. So you can imagine that simply addition of two size classes requires a little time. Now if you have to deal n numbers of grains, that n number may be hundreds of grains, that n number may be thousands of grains or lakhs of grains. So then the mathematical solving or the mathematical calculation by using these fractional values becomes difficult and it requires a lot of time. So people face difficulties, and in those days, in the early half of 20th century, the use of computer, use of calculator were, they are not easily available. So to solve this problem, another famous scientist known as Crambin, he in the year 1934 introduced a method of logarithmic transformation of Arden Wentworth grid scale. What he did, he used the log value of the grain size diameter. Say for example, if we choose this size class, that is the 4, we can, as we know that it is expressed in 2 to the power values, this is the multiplication of 2. So 4 can be expressed as 2 to the power 2. Now in phi scale, Crambin proposed that this phi size, it is denoted as phi, is equals to the logarithmic value of Arden Wentworth grid scale. So we can write here as phi is equal to this size class as 2 to the power 2. Now two adjustments Crambin made in his phi scale. The first thing, Crambin take the base of log as 2. Now we all know that in most of the mathematical calculations, whenever we use log, in most of the cases we use the base of log as 10 or either e. But in Crambin scale, the use of 2 as the base of the logarithm allows direct conversion of Arden's grade scale to Crambin phi scale. So now this, because of this base 2, we can directly convert the Arden Wentworth grid scale into phi scale. Another adjustment is that in nature, as I already told you, mostly we deal with the finer size class of grains. And if you uh, convert these fractional values into 2 to the power forms, say for example 1 by 16 is expressed as 2 to the power minus 4, 1 by 256 is expressed as 2 to the power minus 8. So we get that if we use this formula, it is converted into phi scale by 2. And if we use the 1 by minus, 1 by 4, 1 by 16 value, that is uh, log 2 to the power minus 4 with base 2, then at the phi scale, we get the value as minus 4. So in phi scale, this 1 by 16 millimeter grain size class is represented as minus 4. So we can the fractional number can be transformed to a whole number, but a little bit problem still exists. That is, the most frequently encountered size class, what we found in nature, that is converted in the phi scale as whole numbers but have a sign of negative. So 1 by 16 is now represented in phi scale as minus 4. So to avoid these negative values, negative numerical numbers, Krambin proposed a negative sign before the logarithmic transformation. So now Krambin phi scale is proposed as phi is equal to minus log base 2 and d. This d is the diameter of grains used in Arden-Wentworth grade scale. So from that we can write that d is equal to 2 to the power minus 5. That is the grain size diameter. So by this way, when there was less availability of calculator, less availability of computer, and mathematical calculation was simply done by hand, so then the fractional values of the Arden-Wentworth grid scale, or all the values of the Arden-Wentworth grid scale which are expressed as multiplications of 2, they are converted into Krambin's phi scale into some whole numbers, so that mathematical calculations become easy. But in the latter half of 20th century, when computer, calculator, laptop, and also in mobiles, when they are very much available to people, then people again go back to the Arden-Wentworth grade scale, because nowadays we can simply, whenever we put 1 by 16 and 1 by 256 in calculator or in computer, within a fraction of second it gives us the result. So calculation becomes much more easy. So people did not need to convert the Arden-Wentworth grade scale into the phi scale. So nowadays, again, because of the availability of the technology, Krambin's phi scale is obsolete and people go back to the original Arden-Wentworth grade scale. Now, here you can see certain grains having different sizes. So after knowing the Arden-Wentworth grade scale and Krambin phi scale, now you cannot use any relative terminology that these are large grains, these are small grains. So instead of using these large and small, this relative terminology, now you have to put these grains or put the picture of these grains under a scale. So you have to use a scale and directly measure the diameter of these grains. Now the question comes, if the grains are large, that is if the grains are visible to our naked eye, we can directly measure these grains by using any kind of scale. But if the grains are too fine, say for example, if the grains are of silt size or clay size, that is clay size particle is almost your like a powder. The powder, the talcum powder, what you use during summertime in your home, that is of clay size particles. So those clay size particles, one individual grain selection and observe its character, observe its size or measurement of its size, it's become impossible in naked eye. So thereby, for those fine size grains, we have to put them under microscope, and in modern microscope, we can there is some scales when you observe through the eyepiece. So by keeping these fine size grains under the microscope, we can measure the diameter of the grains, and thereby after measuring the diameter, we have to use the proper scientific terminology followed or following the Arden-Wentworth grade scale. So nowadays, when people use the term sand, they definitely indicate that the grain have diameter ranging between 2 millimeter to 1 by 16 millimeter. When people use the grain size as boulder, they definitely means that the diameter of the grains is greater than 256 millimeter. So in this way, there come a standardization of sedimentary grain size, and the whole world follows this standard method. Now, another important thing which you will come to know whenever you study sedimentology or sedimentary grains, that when the sedimentary grains naturally carried out by the natural agents and deposited in a place in this manner, then there are some spaces within the sedimentary grains. So you can see all these grains are arranged one after another, one above another here also. And within these grains, you can see that there are some open spaces, these gray colored portions in both picture. So these open spaces within the detrital fragments, within the sedimentary grains, are known as pore space. And in a sedimentary condition, when these grains are deposited, these pore spaces are filled up either with water or by gas or by both. So these pore spaces may filled up with simply water or any kind of liquid. Not necessarily it is always water, but any kind of liquid, or they may be filled up by any kind of gas, or they may be filled up partially by water, partially by gas. That means these pore spaces occupying both kinds of fluid. There may be liquid, there may be gas. Okay, and depending on whether the pore spaces are connected, you can see that this pore spaces is not connected with this one. This one and this one is not connected at all. So the fluid, that is the liquid or the gas trapped here, they cannot move from this pore space to this pore space. They cannot move. So if they have to move within the pore spaces, the pore spaces must be connected with each other, and this connection allows the fluid to move from one point to another point in a sedimentary deposition, and that is known as permeability. So that's a brief introduction about the sedimentary grain size, the different methods and their uses, and a brief idea about the porosity. Porosity is the percentage of pore spaces present within the rock compared to the solid matter present in the rock, and the permeability. So thank you.